Good morning, everyone. I will just wait one more minute for Grant to log in and to see if there's anybody else joining us, and then I will start with the introduction. As usual, we will leave mics off and cameras off. However, we are recording the webinar, so by end of this week or next week, it will be available. We always post it on our LinkedIn. We always put a link in our newsletter, which if you are not signed up for, please feel free to sign up. There's a sign up on our website, or you can just email us at info@fordwater.com and I will happily add you. And then we do upload it to our website as well under our webinars tab. At the end of the webinar, we will have a question portion. So if at any point during the webinar you do have any questions, feel free to leave it either in the chat or the Q&A. And at the end, I will read those out and direct them to Grant. He always saves a little bit of time for that. And if some questions are a little too long to answer, or Grant needs more time, or we're running a little late, he's always happy to reach out via email. Okay, well, we gave everyone that extra minute, so here we go. Well, first of all, thank you everyone for joining us for our latest webinar, Test for the Best-DLE Resin Evaluation and Testing Methodology. So one of the most critical and challenging decisions a lithium brine mining company must make in the development of their direct lithium extraction, so their DLE process, is the selection of a DLE media. This single decision will have the greatest impact on the lithium production economics, as the type of DLE media performance will dictate the number of unit processes required in meeting quality requirements and the time required in a production cycle. Since every brine is unique, a DLE media must be selected that can perform within a unique brine and then can be tuned to increase performance. Since there are many different types of sorbents to choose from, with each sorbent manufacturer having its own unique chemical formulation, the result is a brine mining company has numerous sorbents to choose from. So the question then becomes, how do you test and evaluate if a sorbent resin will perform well on a specific brine? In this webinar, we will be reviewing the types of sorbent materials, key performance measurements to be made, the type and configuration of testing equipment to be used, and the common factors and contaminants that can inhibit DLE resin performance. Grant Thornley, who is our VP of Engineering Solutions Sales at Ford Water, will be hosting and will be joining us shortly. Oh, there's Grant. Perfect. We will start with a quick poll. So first, I would like to just ask how many of our attendees today are conducting DLE testing right now? Okay, and then our last poll is how many attendees are using aluminum or titanium absorbents? Fantastic. I will be able to give you the answers to those at the end. And now, Grant, I will let you take over.
Great. Well, thank you very much.
Oh, Grant, we can't hear you. Oh, there we go.
Oh,
there,
sorry.
it works.
Can you hear me now?
We sure can.
Okay, excellent. Well, thank you very much, everyone, for attending yet another webinar in our series of DLE discussions. And without further ado, sorry, always a technical thing here. All right, just make sure I'm sharing my screen.
Mm-hmm.
Good.
Perfect.
Okay, let's start this. And if you just let me know if everything is good.
Yep, we're good.
Okay, excellent. Okay, well, again, thank you everyone for joining us. I know that we're coming up to a year end, so everyone's time becomes a little bit more critical. Oh, do I have my camera on? You can.
Oh,
Okay.
sorry, yes, we can see you.
Okay, excellent. So kind of closing, this will be the last DLE webinar for the year. We'll have some more in the new year. But I thought we'd finish off on the DLE media testing, and just like to say that thank you very much for everyone for your inputs and comments. It is very much appreciative, since in putting these types of presentations and media together, we always want to make sure that there's value and there's benefits and opportunities for our clients. So what further ado is really DLE resin performance testing, the hows and whats, and I'm going to say the whys of what. Oops. Sorry. I apologize for that. Sorry, my mouse is quite sensitive. There we are. Okay. Great. So the challenges in selecting the DLE media. Once you've got your reservoir, your reserves, you've got your JOC, you've established how much lithium's in this and what potential production is going to be. The next is start looking and working on your DLE process. And the first step within that journey is the selection of a DLE media, since that's going to dictate essentially what your pre and your post DLE operations or unit operations are going to be. So it is challenging because there is, with DLE, there is a lot of DLE media suppliers in the market space. I'm going to say more of the challenge is that because there's no real commercial operation short of maybe Sunresin and Livent, which are only two companies in the world operating DLE, there is no DLE operating data in which to reference or draw from. So it becomes very critical in selecting the right DLE media provider, because getting the right DLE media is going to help de-risk your project. Since if I can't rely on historical or operating data, then I'm going to have to make sure that my testing is very high quality to ensure that I've eliminated as many variables as possible. Long-term operation, that's always going to be a challenge, but short-term, I should be able to identify that with my testing and piloting demonstration units. So there's several DLE suppliers to choose from all over the world. There's different which you can get to a large, small, and then there's numerous absorbent types that you can pick from. So it just becomes, numerous suppliers, numerous choices, so it becomes exponential. So this is why I wanted to talk about, how do I select a DLE media, and then how do I test it? So just for reference, is circling back, is that, well, what are we talking about within the process flow or process flow sheet or unit treatment? So we're talking about direct lithium extraction, which is going to that's going to remove the lithium directly from the brine. It's going to and then re-inject the depleted brine back down hole. So the process we're looking at is that, well, the DLE media, the process is going to have to load lithium, or typically go through a wash cycle or a rinse cycle or a displacement cycle. A lot of different terminologies used in the market space. There is no, I'm going to say, common term as of yet. So I do try to put as many definitions here. And the last one is desorption. So regardless of the DLE media, absorbent or ion exchange, these are the processes you're going to run. There are other processes for extraction. It could be using electrolysis, or it could be, excuse me, or it could be solvent extraction. But I'm talking about that since absorption is typically the number one media of choice within the industry right now. Things may change in the future, but right now that's currently what they're being designed, piloted, and demonstrated on. So post-DLE operations, if you make the right decisions, great. If you make the wrong decisions, then it impacts everything. So the contaminants can dictate if I choose a certain DLE media, that the eluate that's produced may have certain contaminants. The type of contaminants and the concentration of contaminants will then dictate what my post-unit processes are. So, I mean, the key or the objective is that I want to produce an eluate that has no contaminants. It's not going to happen as of yet with the technology that we have, but that's what you're trying to do is minimize any contaminants, because then that improves the efficiencies, the OPEX and CAPEX downstream. So next, I mean, different variables, you know, if I a different DLE media that I choose, I'll have different purities of my eluate. It may require a different pH adjustments in pre or post. It may require me to operate the DLE media at maybe at elevated temperatures rather than like 20 degrees, let's say ambient. Maybe I have to go to 60 or 80 degrees. And then other operating parameters, washing, stripping, and so on. So selecting the DLE media is one, but then trying to tune it to the brine to really optimize it is another challenge. And if you get it wrong, there can be serious consequences later on. So I'm kind of working with the clients. I've kind of put together a very high level overview of how to attack the selection of a DLE media. The first one, pretty straightforward, is do your research. Take a look at who the DLE suppliers out there, and really what media is going to best fit your characterization, meaning that if they do have a product specifications or anything available online or anything to get your hands on, and that could be white papers, do your research on that. And what you're going to be doing, we'll touch on this, is you're going to be selecting the DLE media that is synergistic and is optimal, allows optimal use with that particular brine. Different brines have different contaminants and different characterizations that may impede the performance of the DLE media. So the first one is take a look at your brine characterization, what you have in there, and then what DLE media should I select? Is it a sorbent? If it's a sorbent, is it aluminum based? Is it magnesium based, or is it titanium based? Or maybe there's another ion exchange resin, like the chelates and so on. So different materials will perform better or worse according to what the characterization of brine is. So that's the first one. Is kind of a back of the napkin. Okay, what media should I be looking at? Once you've been able to figure out what media that will best optimize my system performance, then I'm actually going to go out and start looking at the DLE suppliers. And when you're doing your evaluation, the process is quite simple. Once I've selected them, first thing you want to do is you want to have a really good brine characterization. Spend the money on that. It's really going to be beneficial to you in conducting this. So like think of like computers, garbage in, garbage out. If your characterization isn't good or a bunch of assumptions, sometimes you have to do that. To try to make the characterization as good as possible, because that's really going to aid in the modeling of the performance of a DLE media. So the first thing is get your brine characterization. The DLE suppliers that you have chosen, you're going to send that to them, and then ask them to run a desktop model. So basically, here's my brine, run some desktop modeling, tell me what the performance and the abilities of the resins are going to be based off of this. And they should be able to do that for you, and it should be done for free. The next is, if that's these are kind of a go, no go. If modeling comes back very positive, then the next is like, great, now I want to see physical testing. So I'm going to broach from a theoretical world to a practical world. I'm going to send them a brine sample. And by sending the brine sample, I'm going to ask, okay, do some preliminary testing. I want you to do a beaker test, or sometimes referred to as a stir tank or tank reactor test. Essentially, it's a beaker. I'm going to put resin into that measured volume. I'm going to pour, typically in excess of brine into that. I'm going to mix it up, and I'm going to see just how much lithium is absorbed from that brine. And then I'm going to do it before and after. How much lithium is in the brine before? How much lithium is in the brine afterwards? And the difference is going to be what was absorbed by the brine. So very, I'm going to say, a down and dirty way of doing that. And then the next, I'm going to rinse it, and then I'm going to go through my desorption. So this essentially, it is a quick and inexpensive way to get some preliminary data via what's the uptake or the capacity of the resin, and what is the recovery of the resin. So those are key operating parameters in which will allow me, do I continue on doing some enhanced testing, or is that the end of this particular resin? Do they qualify or not? So on the beaker test or continuous tank, I mean, a lot of the DLE providers will do that for free, or there might be a minimum charge. Minimum charge is that there is analytical testing, and if the DLE provider needs to send that out, then that charge is going to be transferred over to yourself. But typically free of charge or minimum cost, but it gives you the high level rudimentary measurements of what is the lithium absorbed, what is the resin capacity, and what's my recovery rate. Those are critical components. That's a go. Then I go to enhanced testing. Enhanced testing is simply, now I'm going to send them some more brine, and I have a fixed column. And with the fixed column, I'm going to flow my brine through that fixed column. And from that, I'm going to have measurements taken off of that. So on the fixed column is, now I'm going to start running a cycle where, if this was just a beaker, I throw everything in, now I'm going to actually flow brine through it, and I'm going to take it through the different cycles. So I'm going to take it through my absorption stage where I flow the brine through. I'm going to take it through my rinser or displacement, whereas I'm going to get rid of the brine within the column, and then I'm going to go through my desorption step. And then I'm going to repeat that a couple of times. So whereas the beaker test was just a single, now what I want to see is, I want the DLE supplier, or maybe a third party is doing the testing for you. We've done that for clients. You're going to have them cycle it a couple of times. As a rule of thumb, just so you know, is that you typically, or I should say, in my opinion, is you really want to cycle the resin at least 3 times, sometimes even 5 times, in which to stabilize the resin, meaning loading the lithium into it and getting good stability on the absorption desorption. Sometimes you'll see in the first or second cycles, you'll get your curves, or your breakthrough curves aren't as defined. It means the resin isn't stable as of yet. It's still, you're loading in, you're taking it off. So about 3, should be okay. 5 is probably the maximum you should be seeing. And then you're going to run additional cycles after that. And then when you run the cycles after that, it's common to ask a supplier to run 30 cycles. A lot of them like to run the 5 cycles, and I'll just say that by running 5 cycles, you're really not seeing a lot of volume brine going through it, and you're not seeing, if there was any negative effects, such as microcontaminants being absorbed onto the resin, you're not going to see that at 5 cycles. And that's why you really want to ask the DLE media provider to run it to like a minimum of 30 cycles, because that's going to show the stability, and it's going to show a longer term performance operation of the media than 5 cycles. 5 cycles get stability, but it's really not telling you a lot about the long-term operation. If that all works out, and of course, when you're doing this, you're sometimes you're tweaking the pH, you're tweaking your flows, you're tweaking your temperatures to kind of do some preliminary optimization. Next, if that works, then the go is, then I'm going to go resin cycling. And resin cycling is, I'm going to use a carousel, fixed column, but a carousel. Typically 30, could be more, of fixed columns, and it systematically cycles through. That's a great way of getting a lot of cycles done. If I'm just doing a fixed test column, if I'm going to do 30, I got to keep loading, unloading. So there's some labor components and time associated with this. So going to a carousel, which is more optimized, is going to be a quicker and it's going to be an easier way of doing your testing. So, and when you get into the resin cycling, again, allows you to really optimize the operating parameters of the DLE, such as pH, temperature, flow, sometimes pressure. It's a high pressure geothermal brine. And that will optimize what I need to be, but more so what I'm going to see, because I'm running a higher volume through the resin. It's going to show me really the stability. I mean, it should be stable, but it's going to show me the long-term effects. As I said, microcontaminant loading on the DLE media is not going to be really noticeable at low volumes or low cycles. So as I increase that, if there is going to be a problem, I'm going to start seeing it, 30, 50, 60 cycles, 100 cycles. And if I do see that, that's great. You can address it. But if you didn't do these higher cycles and you did install the media, then the whole plant could come down in very short order. So the intent, the takeaway from doing the DLE testing and selection is really I'm de-risking my project. I'm selecting the right media, and then I'm going to test that media to validate its performance and optimization on my brine. So I de-risk my program. So high recoveries, but a long-term operation, long design. So don't want to be replacing my resin every 2-3 years. It's not be good. So just very quickly, there's lots of DLE media providers to go through. This is a small, I'm going to say a very small list of mine of people that I've talked to or worked with. Again, by no means does this mean this is, there's not others, there are, but this kind of gives you an understanding when I say there's lots of suppliers and different medias, it gives you a little bit of an understanding to it. So when you're doing your selection of media suppliers, as I said, one of the things is great, call up some brine mining companies, maybe in your area, whatever, and ask them what they're doing. Typically, they'll, if it's not public information through their preliminary feasibility studies or their or presentations, investor presentations on the website, you can always call them and ask them. Take a look at, take a look at Google of DLE suppliers, where the pilots are, where they're operating, the pilot plants or demonstration plants. Maybe they're doing a pilot on a similar brine to yours. I'm saying go to these, go to any DLE conference or associated conference. You're going to get a lot of information from that, because people are talking, and usually they share a lot of information in conferences. Another one that I found very useful is that, because a lot of the time the DLE media providers will say, hey, this is proprietary technology, I can't share that with you. If they do say that sometimes, and again, I really want to understand what the resin is, how it's been constructed in media, because I can deduce the pitfalls or potential weaknesses of that media by really understanding what the formulations or what the actual structure is. Is it a lithium aluminate double hydroxide, or is it triple hydroxide? Is it a titanium oxide? Is it meat? That really allows me to understand what their media is, and then kind of the pros and cons, where I should use it, maybe where I shouldn't use it. So sometimes if you go into Google Patents and look up their media, you can find out a lot of information to give you some insight into that. There's also there's more and more white papers being published on that, which is great. So finally, there's information coming into the DLE community. Or lastly, hey, if you want, give me a shout. I will share with you what I can. As I said, clients know that I will share as much as I can possibly share within NDAs, because I really want the DLE market and technology to grow quickly. You can't do that if you live in a bubble. So first things first, when you're evaluating, I know this is going to sound pretty simple, but it's a common thing, is that, well, what simplistic questions that is really going to dictate what your DLE media is going to be, or your media supplier is, First is, what's the product you're trying to make? Is it lithium chloride? Is it lithium sulfate? Is it lithium hydroxide, lithium carbonate? What's the product to market? And that's going to help understand. Next is, what's the required product quality? Am I trying to make, just a bare bones, and provide it to a converter and they'll look after it, or I'm trying to get to a technical grade, or am I trying to get to a battery grade, or maybe better than a battery grade? I need to know that. Why is that important? Because, well, if I've got to get to extremely high grade, well, maybe then the eluate quality or purity is going to be a critical factor. And then what's the targeted plant production capacity? Why is that important? Well, look, if it's a large capacity, some of the DLE media providers that you're dealing with don't have their resin capacity up. So if you say, look, I'm going to be doing a 20,000 or 60,000, 50,000 metric ton a year LCE, they might not have the resin capacity for you. So always check. Know what your production capacity is going to be, because that'll dictate. You'll be able to tell the supplier how much resin you're going to need. Primary objectives, getting into the meat and potatoes of it, is, well, what is the other component? When I'm doing the test, I'm setting and optimizing my process up. I can't optimize my DLE operations for everything. I need to understand what's the primary goal and what's my secondary goals. And then that way I can tune and optimize the DLE materials and operations accordingly. So one is am I just trying to maximize the lithium recovery? Am I trying to get to the highest eluate quality? Am I trying to get as much cycling in from production time as possible? Is there economics? I mean, all those things, yes, they're all factors in it, but one may be more predominant than another. So give you an example. Well, if I'm trying to maximize the lithium recovery, then that's fine. I'll run my cycling right to the very end. That'll do it. But my cycle time could be like double in order to go from 70 or 80% to get to 100%. Then my cycle time or production time basically doubles or triples to get there. So maybe lithium recovery, yes, it's important, but maybe getting shorter cycle times is also important. Or eluate quality. If I want really good eluate quality, then fine. I'm going to take, rather than running to the end of the cycle, I'm going to take a slice or a segment of my cycling at shorter, let's say 60%. So I know these sounds like maybe rudimentary questions, but it really helps in understanding and designing the test program for your DLE media. So a lot of clients say, yeah, every single one of these is important. Again, you can't optimize the design system and have maximum optimization for every one of these categories. There's a playoff or synergy between. Sorry to belabor that. So getting into my sorbent materials and choose from. So there's different types of methods. As I said, there's electrolysis, there's new membranes coming out, selective membranes, such as metallic organic frameworks. There's we're not talking about that. What we're really looking at is what's the predominant sorbent materials that are being used, I should say being designed, piloted, tested, or demonstrated within the market today. As I originally said, there's only 2 DLE companies in operation for Sunrise and Livents, but everyone is moving closer and closer towards that finish line of getting their demonstration and full commercialization. So based off of that, testing, piloting, and demonstration, the majority of the adsorbents being used in the market today are either aluminum-based or titanium-based. Those are the key, which is with aluminum-based actually being more predominant within the market than the ion exchange for the titanium base. That's just it is right now. It may change in the future, but there is the lithium aluminate double hydroxide is typically the most common in the market space. So again, lots of suppliers not pointing that, hey, aluminum is better. Is that just pointing out that's typically what's used in the market, but it should not restrict your research and looking at different DLE media providers. So aluminum-based advantage, every media has advantage and disadvantage. One is that on the aluminum-based, just so you know, different DLE manufacturers that will have a lithium aluminate double hydroxide, some even have triple hydroxide. Even though it's of that category, every manufacturer has different, I'm going to say, permutation combinations of their formulations and different binders and so on, which means that slight changes in the formulation can have significant impacts, advantages and disadvantages of that media. So even though it's a sorbent, it's a lithium hydroxide, lithium aluminate double hydroxide, they're not all the same. They're different. So you're going to have to test and optimize each one of those medias and tune it to your brine. So overall, common denominator for the lithium aluminate double hydroxide is it does have high selectivity for lithium ions. The newer ones, there's a double, which is great, and the newer version coming out is the triple layer, which actually increases the eluate purity. So not a lot have this, but this is what's on the horizon. But even still, without that, still good performance. The challenges or concern is has more of a limited range within pH temps. Has medium absorption capacity in comparison to, let's say, a titanium base, and it's not well suited typically for magnesium, potassium, or brines with high concentrations boron. So typically that's another aspect of it, is that if I had high magnesium and high potassium, very high levels in my brine, maybe aluminum-based sorbent isn't the way to go. Maybe titanium-based is something to look at. So again, understanding, starting off with your characterization of your brine is going to dictate the direction of kind of what sorbent you should go to or what supplier. Titanium-based, just a quick overview, does have a very high selectivity for lithium ions and has a very good, because it's very, very selective, it has a better eluate purity. Challenges, though, is whereas absorbent material, aluminum sorbents are usually eluted or desorbed using water. Titanium-based is a pH swing. I load with a high pH and I unload the lithium with a low pH. Well, it requires acid and bases. And if I'm looking lithium through a green lens, maybe that isn't conducive to what the company's mission is, or maybe of that particular area. Not saying that, look, a lot of the DLE processes are going to reuse and regenerate that acid on site. So it's not 100% waste. It's at, let's say, 60, some 70% is going to be recycled. So minimum reagent waste or waste, but maybe that's a concern. Some areas, on geographic area, some aren't concerned with it, some are. So again, pros and cons, there's a much longer list. I'm just trying to give you a very good overview or a general overview of the different medias. So kind of getting into a little bit of the meat and potatoes of it is, what are you trying to do? When I do my DLE media test objectives, and we'll get in a little bit more detail, what am I trying to achieve? Well, the one thing that tells us the most is my breakthrough curve. You've probably heard that, like ion chromatography or ion exchange resins, very, very common. And what I mean by that is I want to develop, the best breakthrough curve is the one that I've developed very, very high resolution. I can see where it's occurring, but I also, within that curve, I want to try to optimize it. So the breakthrough curve, the inflection point where it goes from a low to a high, I want to minimize that as much as possible. I want to have it very, very sharp, because there's my transition time, and that's going to allow a better eluate quality and shorter cycling time. Excuse me. So that's the objective. So when you take a look at that, if I was to, excuse me, I like to put brine in here and just kind of do a plug flow, so at the very top of this, you're going to have a saturated, and then what's going to happen as I continue to pump brine into this, well, the brine as a plug flow is just going to keep continuing to cascade and flow through the column. So just to break this out, I've got a saturated zone right here. I have my absorption zone, which we also refer to, MTZ is a mass transfer zone, which is this right here. You kind of see this curve. And then as this comes through, then I have the resin below is the unsaturated fresh absorbent zone. But as this moves through, as it transports through, you can kind of see that, well, my saturation zone becomes larger as the mass transfer zone moves down. It keeps going more and more and more, and then finally, that when my mass transfer zone hits the resin capacity, that's my resin exhaustion point. You see that my inlet and outlet concentrations are going to be the same. So a little bit kind of belabored that, but it's important because this is what you're trying to get at. I want to develop this absorption curve, and this is what you should be asking your DLE suppliers for. That's great. They give you a chart telling you I want a good resolution breakthrough curve. And again, what you're trying to see is that it tells you a lot that the sharpness of this curve allows you to infer the dynamics. Oh, there, I'm sorry. The time and the shape of the breakthrough curve indicates the absorption dynamics. So this is critical. If it flattens out, then okay, I want to shorten that inflection. Well, what do I do that? Maybe I change my temperature. Maybe I change my pH, and so on. So there's a lot of information in here. And this is what you're trying to get at. So I apologize for belaboring. Definition, when you take a look at what is a breakthrough curve, this inflection point is hopefully very sharp and short. But on your inflection is that breakthrough point by definition is that when my inlet concentration and my outlet concentration is between 0.05 to 0.09, which is right here. That's where you're going to see, that's where your breakthrough is going to occur. So by definition, get everyone on the same page. So types of DLE media testing. We talked about the first thing you're going to do is you're going to do desktop modeling. Irony is that, or I'm going to say kind of industry joke, is that all the desktop modeling comes back incredible. So that shouldn't be a surprise to anyone. I have not had a single DLE supplier come back to me and say, oh, the desktop modeling didn't work out very well. But anyways, that's another story. So the first is that the jar testing. Jar testing is sometimes referred to as continuous stir tank reactor. But quite simply, what you're doing is it's a down and dirty method, very inexpensive. Typically, clients or DLE media providers will do it for free, or maybe a small fee in which to cover off the analytical costs. Is you're going to load in a volume of brine. I know the characterization. I know what my lithium content is. I'm going to add a predetermined volume or mass of resin. I'm going to stir it in there. I'm going to give it some time. Maybe I heat it. There's a heating plate. And then I'm going to stop. And then I'm going to take a sample of brine, measure the brine, and say, okay, I know what I started with, I know what I finished with. The difference is how much the media, based off of how much mass I've used, has absorbed. So cycle test, as I said, is that I'll get what my resin capacity is, what my absorption rate is of the resin. Next is fixed column test. So this allows me to control. I'm going to start mimicking my DLE operation. So I'm going to control the rate at which I put my brine into it. I'm going to control the rate at which I do my wash or displacement cycle, and then I'm going to control my desorption cycles. So it gives you better control and I'm going to fill this up. I'll just point out this particular column is one of the things that we'll talk about quite shortly is you also want to run your media at different temperatures. Quite simply is that, look, the kinetics of the exchange or absorption improves typically with increased temperature. So you can conduct your test at ambient, and you get a certain capacity or an absorption rate. But if you increase your temperature, you're going to see the kinetics improve and the absorption rate improves. Now, that being said, if you're increasing the temperature, then you're adding energy into your process, which means you're increasing your costs. So all that, again, the economic viability, you need to model that out. But if you're seeing that your absorption is low, the first thing I'd say is, like, look, increase the temperature and see how that improves. So why I pointed that, if you see, this is a jacket column. People have wrapped tin foil around it. They try to jacket it. This is a very effective way that if I do like a heated oil or glycol solution, I'm going to flow that around the column, and I'm going to be able to maintain and control my temperature very precisely while I operate this. I don't want fluctuations in my temperature or variables. So this is a really, if the client doesn't have it or you don't have it, I would highly suggest getting that. And you're going to do, when you do your fixed column test, whereas the beaker is one, you're going to do multiple cycles. As I said, when I do multiple cycles, I mean 3 to 5, I'm going to stabilize my resin, get a stable curve and stable breakthrough curve, and then I'm going to continue on to that, hopefully about 30 cycles, and see what the stability of the operations are. So by doing the fixed column, I control my variables, and it allows me to start optimizing, looking at different things, my pH, my flows, my temperatures, and allows me to start to optimize my process. Next is carousel testing. If everything is a go, the desktop is a go, the jar test is a go, the fixed column test is a go, then the next is the carousel or enhanced testing. From that is I'm going to kind of see these are automated. There's a manifold up here, different suppliers. But essentially these are these fixed columns, but been automated. Anywhere from 20 to 30 to 40 columns on this, and it's going to continue to cycle through from one column to another. There is one thing to consider, that when you're doing your cycles or your testing, is that there's a cycle time for absorption, there's a cycle time for the washing of the resin or rinsing, and there's a cycle time for desorption. When you add all those up, a fixed column, that might be 2 days of operation, or even longer, could be a week to do a fixed column, depending on what my flow rates and how I'm doing it. And if I'm doing 30 cycles, there could be a time constraints on that. There are ways to adjust cycle times, but just pointing out to you is that also take in consideration that these column tests do take time, and the carousel allows you to, I'm going to be able to perform higher cycling at a more efficient and probably better time, better cycle time. So some people do jump from, if the column tests are really good, they may jump and just go to a pilot test, whereas the DLE media provider has a pilot or demonstration, which they can put on site, or maybe they have a pilot at their operations. So, but essentially, what are you trying to accomplish this? When I get to this point, I want to run through as much brine through my resin and achieve as many cycles as possible, hundreds of cycles, not 30, hundreds, because that's going to tell me what the long-term stability and the operating performance of the media is. One of the challenges that we have on optimizing and trying to model this out is sometimes there's microcontaminants, very, very low levels within the brines. What happens at the initial low-level cycling, they're not going to see any performance impediments, But as the contaminants load up and block those fast sites and prevents the lithium from being absorbed, then you start seeing performance drop down. And you may not see that until like 100 cycles. So that's why it's so important to do, try to push through as much brine volume through the resin cycling, because that's going to show you if you're going to have performance issues later on and impede it. But again, one of the key things whenever I'm doing design is how do I de-risk this project? I want to remove as many variables as possible and not expose the client to any undue duress or stresses within their options. So sorry to belabor that, but very, very simple is that no matter which DLE provider you go to, they're going to run through the same types of media testing and equipment. So I've selected my media supplier. I kind of know what my objectives are, and I'm all ready to kind of start doing my testing. Well, the first thing is that we've got to do is develop a test plan. Again, different DLE medias will operate differently. So a test plan is essentially, again, first thing I'm going to do is I'm going to look at, I'm going to design it through the lens of, well, what's important to me. Is it eluate quality? Is it lithium recovery? It's a cycle time. And you're going to work with the DLE media provider on developing that test plan. And the test plan is that, I'm going to develop one for my absorption stage setup, and I'm going to develop one for my desorption stage setup. What does that look like? Well, one is that I'm going to do, well, how many columns am I going to be using? Typically, let's say it's a fixed column, it's going to be a fixed column test. So one, but I could sometimes, what DLE media providers do is that, well, they do a dual column. I'll put 2 columns in series, and it improves the performance, because what happens, any breakthrough coming off of the first column, as you can guess, I mean, the tailings are going to be absorbed onto the second column. So your absorption rate is going to be very, very high. Now, that being said, one thing to stay conscious is that if when you do your testing, make sure it's consistent. Is that tell the DLE media provider that, okay, I want the columns, I want 2 columns, I want them in series, or I want a single column. What I've come across is that we go through when I'm analyzing or evaluating data for clients is I look at it and go like, well, that's really great. But once you drill into it, it's like, well, wait a minute, they're using 2 columns or double the resin versus this single column. So as obvious that is, sometimes it gets missed if you're only looking at spreadsheets. So very important. So what's the configuration? And then the rest of these are very straightforward for calculations. It's my diameter, my height, how much resin volume I have. The other thing is I want to know, I want to have a freeboard space above my column as well. I want to know what the flow velocity across the resin are going to be, and so my going flow rate. So these are the preliminaries that I require. You're required to do your test plan setup, because this are going to be used in your calculations later on. So just a quick chart, fill in the blanks here. Any questions, just give me a shout. Preparing DLE media. When you, this is really touches on is that sometimes the DLE media provider is going to say, look, I will send you media and you do it, or a DLE media provider, they're going to do it at their facility. Either way, if you're going to be doing the resin testing at your facility, or you're going to hire a third party to do it, you really need to know what the condition of the DLE media is before you do your testing, and whether you have to do some preconditioning. So sometimes because if you're doing lithium aluminum double hydroxide, you're using lithium in the manufacturing of it. So if they just send you the lithium straight off the press, so to speak, to you, and you run your test, lo and behold, you have this incredible lithium measurement coming through. It's because you've got residual lithium from the manufacturing process that has to be washed off or rinsed from the media before you do your testing, or else that's going to skew your results. So understanding the precondition of the resin is critical before you stop. So other things is that maybe you've got to hydrate it. I've got to soak the resin in water to hydrate it. Or maybe there's some other media tests you have to go through. But the DLE media provider should be able to provide that. As I said, I've seen that run through. It didn't do pre-treatment, and the lithium levels are too high. It looks great, but because it wasn't washed. The other thing, you might have fines. You want to precondition backwashing, like a typical ion exchange resin, to backwash the fines. So, what's a fixed column test setup look like? If you're doing it, or the client. And again, while we're going through this, it may seem a little tedious or mind-numbing, is that it's critical that when you do your evaluation, comparing one to another, that all the test plans, and more so the test apparatus, is set up in the same way. That way it's going to be easy to do your comparison. So one of the things, just a quick, this is a down and dirty diagram, but you see, well, here's my resin column, and you'll see that I usually put a screen here and there's some glass wool to ensure that it traps the resin from going through. And then I'll fill my column, and then again, your DLE media provider may say, hey, there's different ways of filling your column. Maybe I fluidize and put it in, or maybe I can just dump it in. There's some nuances to it, but let's say I fill my resin column. I'm going to put some glass wool on top of this, and away you go. Well, why do I put glass wool on this? It's if you work with ion exchange, one of the critical things is I don't want to disturb the resin bed, and I want to develop a plug flow, meaning that I want to have a very laminar flow of the brine through the media, and not turbulent, where if it was turbulent, then the brine is going to flow over here, and I've got some free resin here. I want plug flow working all the way through. That's going to give me my best performance and efficiencies. And that's why you put the glass flow, because anything dripping in, it's going to basically nullify the turbulence, and it's going to allow that laminar flow. So minor thing, but make sure there's some glass wool in there to ensure that. So your different cycles, and then you talk about the flow patterns. Typically, you're going to operate your absorption. I'm going to feed brine into the top of the column in a downflow. It flows from the top to the bottom. My resin rinse, an option. I could flow it. I could do reverse it and do an upflow pattern, but really for typical fixed column, I typically do everything in a downflow pattern. But you could change, and then your desorption the same way. So in your rinse, your resin rinse water, with some variabilities to it when I go through. Typically, I want to again, if it's a plug flow, I want to my resin rinse or a displacement cycle is by definition is that I've loaded this up with brine. Now I want to basically displace all the brine out of there before I start my desorption cycle or wash water. So just getting into the variabilities now. So when you're talking the DLE for like temperatures, as I said, is that a lot of say, okay, we'll run it at ambient. Well, that's great, but I want to understand if I run it at 20 or 30 or 40 or 50, how does the kinetics change? How does the performance improve of the absorption and desorption of the medium? And from that, when I have that curve, I can select within that curve, well, what's the best performance? What's the best temperature, and which will provide me the best kinetics or performance of that medium? So I would typically ask at least get 2 points, in which you can kind of extrapolate from the medium. But just don't do one. Do yourself a favor, get at least two temperature points in which to kind of see what the difference is in the absorption and desorption. The other aspect is that sometimes people ask, okay, do I, this is a side note for absorption, desorption, say, okay, well, for desorption, I'll heat it up, and absorption, I won't. Just so you know, there is, if the temperature gradient, this is a media, so think of it as it's a solid media or material, that if I have a very large temperature gradient between my absorption and desorption, I can thermally shock the media and cause it to fracture. So just so you know that if you increase one of these temperatures, you typically have to increase not to the same level, but I want to make sure that I don't have thermal shocking occurring. So I will have, if I adjust one, if I increase one, I'm going to have to adjust the temperature of the other. So not a critical, but when you start talking about the economics on the energy side, resin wash water, this is the eluate. If I'm using lithium aluminate double hydroxide, then I'm going to dilute with water. If I'm using something like a titanium oxide or a titanium base, then it's a pH swing, which is I'm going to load high, deload low. So I'm going to use acid and bases. This particular discussion, I'm just using water as my eluate. So when you talk about wash, when you're developing your plan, okay, great. I've established what the temperatures I want to be tested at. Also, what the flow rates are going to be. Just so you know that if I can adjust that, the higher the temperatures, then because better kinetics, then I can reduce my flow rate, and vice versa. Lower the temperatures, probably the higher the flow rates. Sometimes that comes into play that if I want to do a really quick testing of my absorption, well, maybe I'm going to conduct it at high temps because it will be a lower flow rate, which means shorter cycle times. And then wash waters. One thing just to point out, which I find time and time again, I don't understand this, is that remember when you're working with lithium aluminate hydroxide, or double hydroxide, there's lithium in the crystal structure. And if you wash that resin with a high purity water or DI water, you're going to get great lithium recovery initially. Extraordinary lithium recovery, because what's happening is you're literally sucking the lithium out of the crystal structure, the matrix, and you're destabilizing, you're going to collapse the resin. So again, you're running 5 cycles, that's great. You're not going to see anything. But if you ran 30 cycles, you would see the lithium basically destabilize and collapse on itself. So I don't know if this is tricks in the industry or not, but whenever you run lithium aluminate double hydroxide, if anything you take away from this presentation, you always want to have lithium in the wash water to stabilize the resin. Now, different DLE media providers will offer up anywhere from 50 to 300, and you decide. The reason you want to put it will stabilize the resin. So it's, again, you're not losing the lithium. You need it to stabilize, and make sure that they are doing that. And one other key thing is that if you're putting lithium into the wash water, make sure that the lithium is accounted for in the mass balance when they're doing the recovery rate. I've seen this a couple of times, is that they don't do that. The lithium looks great because they're not accounting for the lithium that they're putting into the element. It's a quick little thing for you. Sample frequency. So I'm running my testing. I'm running my cycles, and what I want to do is I want to take fraction sampling off it. So as it's dripping through, I want to keep taking samples at different bed volumes of the resin along that cycle time. And typically your fraction cycling rate, think about a half bed volume is really good. And the one thing to point out to this is that just because you do sampling doesn't mean you have to do the analysis. Because what people say, well, the more sampling I do, well, that's a higher cost. if I haven't sent out for analysis. You're right. However, and I'd really stress this, is that when you're doing your enhanced testing, your fixed column, ask the DLE provider or have your technician, take sampling, fraction samples every half bed volume and store that. Because later on, maybe you want to go back and develop a really, really high resolution breakthrough curve. Well, I don't have to rerun the test. I'll just run the analysis with what I have. So doesn't mean you have to do it right away, but do yourself a favor, do frequent sampling in order to develop that high resolution or the ability to go back and take a look at something that might be of interest. So a lot of the times it's that you're going to be running your samples through atomic absorption or whatever. Again, do enough samples that you develop a half decent curve and hold on to those fraction samples for later on. Again, it's not going to cost you anything, but trust me, is that later on you're going to have a question and you're going to have to rerun the entire test. Whereas other clients I advise, we've been able just to go back and analyze that particular, where we are in the fraction sample and in the curve. So fixed column, I'm just going to kind of skip through this. I apologize. We're at 11 o'clock now. Testing equipment, atomic absorption, induced coupled plasma, conductivity meter, pH. These are the instrumentation and the instruments you're using. A lot of people use atomic absorption when they do the fixed column because it's very inexpensive to do. So you have a lot of samples, whereas a lot of people do not have an ICP or induced coupled plasma. They've got to send that up, and anywhere from $100 to $200 a sample. So typically do absorption. I mean, it's a good instrument, but when you get to a point that you really, really want to validate, send it out and spend the money on an ICP mass spec. Just getting into the end, just to finish up. So what are the measurements? So I've really spent a lot of time doing that test plan, setting it up. How did the operations, the variables? This is now straightforward. It's that here's the type of measurements that I'm going to ask the DLE media provider to supply to me. I want to know what my absorption capacity is. I want to know what my selectivity is with respect to my eluent. I want to know what my separation efficiency is, meaning my sodium to lithium ratio. That will tell me what my efficiency is, or my potassium to lithium, or calcium to lithium. I want to know what those are because then I can compare those. I want to know what my regeneration cycle times are, my absorption, my washing. You can go back and take a look at this. The thermal stability, as I increase my temperature, what's the difference in the kinetics, my extraction time. So these are typically what I ask and how I basically evaluate and rank different DLE media providers working with clients. And then I have my weight score and so on. So all this, so now what am I looking at? Okay, just coming to a conclusion here is, here's different curves. Is that I've got my desorption ratio of lithium. I can develop these curves. I can also, here's an inflection point and breaking through as well. So that is the end of our presentation. I'm sorry, we're at 11 o'clock. I really appreciate your time. Hopefully there's still people online. If you have any questions, I'm more than happy to take them now.
Perfect. So going back to our polls, everyone that answered was conducting a DLE testing right now, and it was 50-50 whether they were using aluminum and titanium absorbents.
Interesting.
And there's someone that is typing in the chat, so we may have a question coming in.
Sure.
Oh, great job. Yeah, we'll just give it a second.
Sorry. So you mentioned there are two commercial lithium sorbent providers. Sun Resin was one. Just wondered. what was the other? So the other one, so Sun Resin has commercial operations. Majority of them are in the western part of China and in the salt flats. They have one or two, they're looking at development one or two plants in Argentina, Chile. So that is Sun Resin. And the other one is Livent, which was acquired by Alchem, and which is date myself, which is used to be FMG way back. So acquisition after acquisition. So that's the other one. So right now, really, there's only two commercial DLE operations in the world occurring, which is Livent, via Alchem, or Sun Resin.
So what is the suitable ppm range of lithium in brines in order for sorbent to work well?
So excellent question. So this gets into when you're doing the selection of the DLE media, one of the things is that particularly DLE is able to unlock, I'm going to say, low lithium concentrations. But excellent question is that what is that lithium concentration? Typically, my opinion, in doing the test, is that I would say for lithium aluminate double hydroxide, around, I'm going to say 120, 150 ppm for the economics of it. But if you go to like a titanium oxide, which is more conducive of ion exchange, I can go significantly lower. So I could go down to like 50 ppm. So I think it's a good question because it differentiates, from a lithium aluminate to a titanium based off my characterization. If it's low lithium, I'm going to go like a titanium. I'm not saying that that's the only reason you could use titanium from 50 all the way up to like 1,000 ppm, but lithium aluminate double hydroxide, I would start around 100, 130, 150. That's where I see the economics.
Okay, there's quite a few questions that have come in, Grant. So in order here, I've read about the PureTech Sun Resin rotary valve for carousel testing as compared to ones with lots of individual valves or those that can literally rotate on a base. Can you comment about the performance of each of those systems?
Those are excellent questions. I'm going to keep my opinion to myself, but I'm going to say here's what the messaging to the market is. That the carousel, they're saying, look, we use a carousel because it does away with pneumatic valves and so on. They're saying, well, pneumatic valves can fail, and that's why you've got the carousel. So look, there's a pro and con to each. If I go to a carousel, I significantly reduce the number I'm going to say pneumatic valves, or let's say valves associated to that in operations. However, let me point out, doing this for 30 years, I've never really come across issues with pneumatic valves failing. Yes, there's more, but I've never had a cascade failure of 100. I might have one fail. Whereas a carousel, my concern would be that if the carousel goes down, then that whole production cell goes down versus one pneumatic valve. That's my opinion. That being said, that a lot of people are moving towards the carousel because there's a lot of efficiencies associated to that. You have to weigh the pros and the cons and the relative risk exposure of each one of the programs. If you want to talk more about, just give me a shout. Take one more question because we're running out of time.
Okay, so I was wondering your opinion on which DLE company is more suitable for Chile, specifically looking to the Salar de Atacama and Maricunga Salar.
The biggest areas, right in the lithium triangle. So excellent. I'm just going to jokingly say that if you can survive the altitude, then yeah, that's a great spot to go. From Canada, 30,000 feet is a little high for me. But sorry, to your question, look, there's lots of DLE media providers out there, and I think that they are very good. One thing I take a look at, not only take a look at we didn't touch on this, when you take a look at the DLE technology, you also have to take a look at the DLE company itself. I touched on resin capacity, But you should also, there's DLE companies out there that are saying, look, I'll look after the supply of your reagents. I'll look after the supply or the management of your waste disposal. I'll look after the EPCs. I mean, that's like a complete turnkey system from these EPCs versus I'll just supply you resin. So I always take a look at the resin company, because remember that your brine, your production, the production from that mine could be 20 to 30 years, and you really want to have a good partner, not a one and done, whereas I bought the resin and then they're nowhere to be seen. That resin is going to be operating a very long time. There are going to be, you know, that under any project or operations, there's going to be upsets or challenges. So the real testament and why you want to be selected from your company is that how are they going to solve that problem? What are the resources they can throw behind that? Because I cannot afford, you know, interruptions or unscheduled downtime in my operations. That's millions of dollars a day. So that's a key thing to take a look at. Might be phenomenal technology, but they don't have the resin capacity. They don't have the bench strength of the engineering or technical. Again, maybe they will get it. But look, if you're trying to start up, you need to evaluate the company just as much as the technology. So sorry, maybe a cryptic answer. A lot of good companies out there, but that's how I would direct you on who to take a look at. Give me a shout. I can discuss and give you, you know, who's operating show.
Fantastic. Thank you. There's 2 more questions. Grant, would you like to answer those maybe via email? Or should I go for it?
I'll answer those in emails.
Perfect.
And I'll respond to you today. But again, thank you very much to everyone. I know this is a very high level overview of the DLE testing. If you have any questions, please give me a shout. I'm more than happy to share my spreadsheets and the data and benchmarks that I have in the industry, as well as, you know, what our capabilities are to support and help you. So that said, thank you very much.
Thank you so much, everyone.
Take care. Cheers.